All right, good morning. So today you are working on a rock pocket mouse mutation activity where you're going to look at this rock pocket mouse population and look at a gene called MC1R. And what you're looking at is if it's mutated or not in terms of what hair color the mouse will have. So what you're going to do is as you look at the assignment, you really need to read through this background information. It gives you good information about the mice population, the gene, and also this information about gene mutations. When you get into the activity, you're going to have to answer some questions about the type of mutation that you see. So the types of mutations that you're looking at could be a substitution where one letter gets switched for another one, and that affects just one nucleotide. Or there could be an insertion mutation where an extra letter gets inserted. The problem with that is it shifts the reading frame. And so that leads to what's called a frame shift mutation. Or you could have a deletion, which is when one gets lost, but that can also lead to a frame shift mutation. So depending on where that happens and what in the transcription sequence can determine kind of how detrimental it could be. There's three different things that could happen to the protein. You could get a silent mutation, which is when there's no change in the amino acid. It codes for the same thing, and the organism would never even know that there was a mutation that happened. You could get a missense mutation, which is just a change in one amino acid. So in the TED Talk, when they talked about cystic fibrosis, where there was the change in one letter leading to people with cystic fibrosis, that's a missense mutation. It changes that one amino acid, which completely changes the protein. That's part of the mucus breakdown within your lungs. And then a nonsense mutation is when it gets a stop signal either too early or a stop signal too late, and so the protein is drastically changed from that. Okay, so what happens then is, like with a nonsense one, it's way different, and then the protein might not even be used or workable at that point. MC1R is the protein that you're looking at. This is where it's at in the plasma membrane. So you have an extracellular part and an intracellular part, and then a transmembrane part. And it's a G protein. We'll talk about those when we do cell signaling. So for now, just know that it's a protein that helps to trigger the production of melanin. Okay, and there's two different types. You can have the eumelanin or the pheomelanin. Make sure you watch this video. It gives you really good information about the mice. It talks about the gene, gives you really good background information. Okay, so then the activity itself, you're going to transcribe the MC1R transmembrane section of the protein. So this is amino acid number 208 to 212, which means this is 208, 209, 210, 211, and 212. This is the the DNA that codes for the mRNA. So you would go C bonds to G, A bonds to U, C bonds to G. To get the amino acids, you have to use the codon chart. So that's where you're going to click on your codon chart. And then you're going to look at the sequence that you get there. So the first one was GUG. So as I look at my codon chart, as it's loading up here, so if I look, I get G and then U and then G, so it codes for valine. So then my amino acid that I would put here would be valine. And then you're going to do the same thing for the mutant. So this is the that causes them to have the dark color. What you're going to do is then look at it and decide if there's anything that's different between in terms of the mRNA, but no change in the amino acid, then you have a silent mutation. If it's a missense mutation, meaning that it just alters the amino acid, then you're going to put the star. If it's a nonsense mutation where you're getting a stop codon in the middle of this, because since it's transmembrane, it's the middle of the protein, then if you get a stop codon, then it's going to be a nonsense mutation. And so then you put that symbol there. The rest of this chart, and then what the second part is to determine the chemistry of it. So you'll click on this, and based on whatever amino acid you got here, so we had valine. So when I click on this, I look for valine, and valine is nonpolar. So when I go back to my chart, my nonpolar is green. So I'm going to take this, I'm going to use my little paint box, and I'm going to color it green. Okay, then you'll do the same thing for all the other ones. just like the way that it was explained. Okay. Then, as you look at the rest of this, this is done for you. So this is the extracellular part, this is the part that you just did, and then this is the intracellular part. It's color-coded. This is the wild type. That's why there's no symbols on it. And then this is the mutant. So what you're seeing is there's 1, 2, 3, 4 places where you have this missense mutation because they're starred. So then the amino acid position number is, I would look up here, and my first mutation is right here. So I'm going to go, this is 15, so 15, 16, 17, 18. So my location is 18. My type of mutation is that it's a missense, and that it changed the amino acid from arginine to ARG to CYS. Okay, so I would put that here. So it changed the amino acid. All right, you'll do that for the other ones. And then you'll answer these couple of questions thinking about what's happening. And then down here is where you're going to talk about the chemistry. So when I go back, my amino acid mutation was at location 18. So the wild type was red, which means that it is electrically charged, and my mutation is blue, which means that it's polar. So then when I'm filling in this chart, this was electric, I think it's positive, and this is polar. Okay, so you're going to record that based on the colors that you see up here, and that's using this chart. Okay, so then you'll get that chart filled in, answer these couple of questions that are there, then you'll use all that information together to talk about how the change in the MC1R protein affects their coat. Why is it when they have the mutated that they are darker coat colored versus lighter coat colored in regards to what's happening with the amino acid changes, okay? And then there's a couple of application questions to answer there too. So hopefully that's helpful, and I will see you in class the next day.